Now let's proceed to the next level. We have what we call stability of a body. Now, how do we explain the stability of a body? You know, when a body is in equilibrium, there are different categories of a body being in equilibrium. There are different categories. Number one, we have what we call stable equilibrium. You understand? A body can be in equilibrium and it could be stable. A body can be in equilibrium and it could be unstable. And a body can be in equilibrium and it could be neutral. So those are the three major classes of equilibrium. You understand? When a body is in that state. Now, we have a body is said to be in equilibrium when displaced slightly and it still retains its original position. What do we mean? If we have a body here, I'm talking about stable equilibrium now. We have a body here. If you look at this body, this is said to be this is a cuboid shape. Now, if I tilt this keyboard now, keyboard, just push it a little bit. Now you realize that it's not going to fall over, it's not going to turn, it's just going to shake, probably it move towards this direction, the shape will still remain. So that particular phenomenon is what we call stable equilibrium. It means that the body, the keyboard, is in a stable equilibrium. Now, the next one we have what we call unstable. An unstable equilibrium object is, body is said to be an unstable equilibrium. When on receiving a slight displacement, it tends to roll over. Do you understand? It tends to move from its original position to another position, meaning that the initial shape or the initial status of that body is known. Let's look at this particular object now. If I tilt it, let's say it's standing towards this direction, it now rolls over, it now turns to something like this. Let's say it rolled over and it turns to something like this. You realize that the position has changed. This is position A and this is the position B. So this particular body is said to have what? To be an unstable, you understand? To be an unstable equilibrium. It's in a state of unstable equilibrium. So that analyzes that. Now, based on your neutral equilibrium, the body is in a neutral equilibrium when on receiving a steep displacement and it tends to come to the rest in its original position. Look at it. Neutral equilibrium. The body changes. Do you understand? But it still goes back to its initial position. E.g., a cone resting on the what? On a curved surface. Now, a ball or an orange rolling on a horizontal surface. So those particular body tends to be what? Neutral equilibrium, because they leave their initial position and they still what? Retain their what? Initial position. So those are the three analogy when it comes to types of what? Equilibrium of what? Body. Now let's go to equilibrium of body in a liquid. When you immerse a solid object in a liquid, it tends to become lighter. Now at that junction, if you must have experimented it, you realize that each time you went, okay, let's say you visited a well and you're about to fetch some water. Now by the time you dip in your fetcher in that well, you realize that the point at which that particular fetcher hits, now let's say this is your fetcher, the point at which it hits the surface of the water, in the well, you realize that the weight, the tension on this fetcher tends to reduce, meaning that you are pulling it down. By the time it gets to the surface of this water, the surface of the water takes little of the weight of this body. So up there, you won't be feeling any weight anymore. So it means that that's the phenomenon we're actually trying to look at. So if you look at the statement, say consider the experience when a bucket of water is being drawn out of a well. While under the water, the bucket appears more lighter and becomes very heavy when it comes out of the water. Now, let's look at what happened. It was Archimedes, a physicist, a scientist, that came about that explanation. He said it was Archimedes who explained this puzzle, that while in water, it is being acted upon by upward forces. That's your Obtuse. Do you understand? So it means that the tendency for the body to become less weight. When I say less weight, that is the weight of this body on this water is no more what? Heavy. So what is actually taking place there is what we call Obtuse. Obtuse. So an Obtuse is exerted on this body. That's an upward force. Do you understand? When the body is actually coming down, an upward force is being applied. And that upward force is what we call the Obtuse. So let's proceed. He said, therefore, if the pull in the rope is T, that is the tension on the rope, therefore the equilibrium of the bucket is given as, meaning that the tension of this rope is given as weight minus upthrust. That's the fundamental equation when it comes to Archimedes principle. Tension, you know, of course, your tension will be in Newton, your weight will be in Newton, and your upthrust will also be in Newton. So Archimedes principle, let's now state what Archimedes principle says. Archimedes principle states that when an object is partially or fully immersed in liquid, it experiences a loss in weight or an upthrust which is equal to the weight of the fluid displaced by the object. What do we mean? We place the object on the surface of this water. Look at how it works. The body has its own weight. The weight can be felt from here. It can also be felt here. Now, when it lands on the water, it's being experienced by an upward force. So the equilibrium, for you to obtain the tension on this rope, you must subtract the upthrust from the weight. Now, Archimedes principle now says that the upthrust that is being experienced here is equal to the what? To the weight of the fluid displaced. Meaning that upthrust will equal to volume of liquid times density. And this volume times what? Density of water. Are we getting it? So from here now, we'll be able to obtain the fact that your upthrust here, which is being obtained as volume times density, can also be substituted in here, which will now give you your tension equals weight minus what? The value of your upthrust. Now, also, you can see for half of the solid is a mass then. Do you understand? That is, if half, let me draw something else here so that you get the gist. Here, we have the surface of the water. Now, we have a stone be suspended by a rope. Now, this stone is fully immersed. When a stone is fully immersed in water, then your upthrust will become volume times density of water. But when an object is partially, that is, half of the object is what is immersed in that water, let's say this is the surface of the liquid, then your upthrust is not going to be this, but half of it, that's half times volume times your what? Density of water. So these are the two equations that we need to note. When the object is fully immersed, it gives you an upthrust of this. When it's partially immersed, it gives you an upthrust of this value. So let's proceed. Let's look at flotation. Some objects can definitely flow in water. You place them, they will just float. While some, immediately they get in, they will just what? Sink. So this is float. This is an object that is floating. Object floating. Now, this is an object that sinks. Now, why is it that some object floats? Whether they have internal volume or vacuum or not, and some sinks. This principle, by the time we are done, we'll be able to explain to us why we have our warship. You know, when it comes to those what do you call it, ships, you know, those boats, ship, canoe, why they float on water. We'll be able to explain this. We'll be able to explain that principle after this. Now let's look at flotation. Let W be the weight of the object in water, and U be the upthrust. We consider three possible phenomena. Now, if your weight is greater than the upthrust, remember, what did we say upthrust is? We said upthrust is the upward force being experienced when an object is being placed on what? Water. That upward force. Now, if the weight of that body is greater than that what? Upthrust, definitely that body will sink. The body will sink. It will not float on water. What are we saying? If we look at this now, this is a body. Now, this body tends to float on this water. Why? Because the upthrust is greater than the what? The weight of that body. That is why the body will what? Float. If it's not greater, as in if the weight of this body is not greater than the upthrust, the body will sink. Hope we are getting all those analogies. Now, the second point is that when your weight is now less than your upthrust, and that's what I just said, the body will just rise upward. It's not going to float. It will just rise upward. But it is only when your weight equals your what? Upthrust, that body will what? Float. That is, it will what? It will just rest on that water. So meaning that your upthrust must not be, if it's greater than your weight, there is issue. If it's lesser than the weight, there is also another issue. But it only floats when the weight of that what? Body is equal to the upthrust. Now, to analyze the above statement, one can say that if a body is denser than that of a liquid, it will completely sink in it. But if the density of the body is less than that of the liquid, you can see that's what we're actually trying to talk about here. If the density of that body is lesser than that of the liquid, the body sinks until the weight of the liquid is not equal to the weight of the body. So that analyzes the fact that a body will only float when your weight equals the updraft. Now the body then floats and said to be in equilibrium. That is, the condition necessary for the body to float is that the weight must be equal to what? The updraft. I think we have analyzed that. A floating body displaces its own weight of the liquid in which it floats, or a body floats when the updraft exerted upon it by the fluid is equal to the weight of the body. So that is the definition of your what? Flotation. What we mean by flotation. So let's go to another good topic which you are going to like love so much. It's one of my favorites while I was in your level, you know. Now we'll be looking at density and upthrust. Looking at density and upthrust. So here now we're looking at number one. We're looking at density. What is density generally? So it's the general fact that a given volume of one material has a mass different from that of the same volume of the other material. Now, for example, we believe that iron is heavier than wood. That has been noted. That means that any given volume of iron is heavier than what? Wood. Now, that's what we call the density of substance is the mass per unit volume. That's just the definition. If you have been